Today we are starting exercise 1.2. So before starting this, we must understand the properties of radicals and exponent and the concept of what are radical and exponent. So I write a radical expression, that is cube root of 8. So here the sign, this is called a radical sign. Eight is called radicand and 3 is called the index. I write an exponential expression, that's 6 power 3. So here 3 is the exponent of 6. Now we will learn the properties of radicals. That is the product of two radical expressions like nth root of a multiply with nth root of b. It can be written under a single radical, can be written as a product under a single radical with the common index n. This is called the product rule for radicals. Similarly, if two the radical expressions are divided, like nth root of a divided by nth root of b, so we can write them as the division of ab under a single radical sign with the common index n. This is called the quotient rule for radicals. Now we learn the properties of exponent. If there are two exponential expressions like am multiply with an, here you can see base is same, so we can add powers, that equals to a power m plus n. So this is called the product rule for exponential expression. Product rule. Similarly, if two exponential expressions are divided like am divided by an, that equals to a power m minus n. And this is the quotient rule. Quotient rule for exponent. Third property is if the two exponential terms have a common exponent, that is n, so we can write it as an and bn. We apply the power separately on both the numbers, that is equals to an and bn. So we call this as the power of product rule. Fourth property is that if the two numbers are divided with the common exponent n, so we can apply the power separately on both the numbers as an divided by bn. This is called the power of quotient rule. Fifth property is if two numbers are divided with the negative exponent, that is minus n, so we make the power or exponent positive by interchanging the position of numerator and denominator. That is, if b become numerator and a become denominator, the power become positive, that is plus n. So this is called the negative power of a quotient Today we are going to start exercise 1.2 question number 1, that is, by using property of product and quotient rule for radicals, write each expression as a single radical and simplify. So question number 1 is the product of two radical expressions, that is cube root of 6 multiplied with cube root of 6. So by product rule law we can write these two radicals expression under a single radical with index 3, that is radical of 6 dot 6 and index 3. This is the product rule law for radical. Now 6 dot 6 means 6 multiplied by 6, that equals to 36. So we replace this by 36 index 3 and under a radical sign 36. So this is a representation of two radical expression as a single radical expression. So we can write them as single radical. Now we will simplify it. So we will write it in an exponential form, that is 36 power 1 by 3, exponent 1 by 3. Now we will factorize 36, as we know that 6 square equals to 36. So we will replace 36 by 6 square, that is 6 square whole power 1 by 3, and the final answer is 6 power 2 by 3. Which is the simplified form of both the radical expressions. Now the second question is radical of 4 with index 5 and radical of 8 with index 5. We have to simplify it. So first we have to make the base same. So we will factorize 4 and 8. The factors of 4 are 2 cross 2 and factors of 8 are 2 cross 2 cross 2. As base becomes same, now we will write both the radical expression under a single radical sign with index 5 by product rule law. So here 5's are 2 are 5's time here with index 5, that is equals to 2 power 5 under a radical sign, that is equals to 2 power 5 with index 5. So this is the representation of both the radical expression as a single radical. So we will write here a single radical. Now we will simplify this radical expression by writing it in exponential form, that equals to 2 power 5 whole power 1 by 5. As powers are same, first one is numerator and the second is in denominator, so cancel each other and the final answer is 2. Question number 3 is the fourth root of x multiplied with fourth root of x cube. As base is same, so we will apply product rule law by combining both the radicands under a single radical sign with the index 4, that is x multiplied with x cube and index 4. So by product rule law, if bases are same, so we can add their powers, like x power 1 plus 3 with index 4, that equals to x power 4. So this is a single radical expression. Now we will simplify this by converting it into an exponential expression, that is x4 power 1 by 4. Powers are cancelled to each other, so the final answer is x. Question number 4 is the square root of 10 multiplied with cube root of 11. So for product rule we know that we have to make it possible to make the base same. Here bases are not same, so we can write as the bases are not same, so we cannot apply product rule. Question number 5 is the fourth root of x power 7 divided by fourth root of x power 5. This is the quotient form, so we apply the quotient rule, in which both the radicands are right under a single radical sign with a common index 4. This is the quotient rule. Now we will combine both the radicands by writing numerator radicands as denominator radicands as numerator. When it become numerator, its power become negative, so that is x power 7 multiplied with x power minus 5. Now we will apply a product rule law, that is, if bases are same we can add the power, so we can write them as x 7 minus 5 with the index 4, that is x square with index 4. So this is the representation as a single radical. Now we will simplify this radical expression by converting it into a exponential expression, that is x square whole power 1 by 4. Powers are cancelled to each other, 2 1s are 2, 2 2s are 4, and that equals to x power 1 by 2. Now in sixth part, this is a cube root of 5000 divided by cube root of 5. So first we have to make the base same by converting 5000 in form of 5, that equals to 5 multiplied by 1000. So this is cube root of 5 multiplied by 10 cube divided by cube root of 5. Now by product rule law, power of product rule law, we apply the powers separately on both the numbers by converting it into an exponential expression. Here product power of product rule, we apply the power separately on both the numbers of numerators, that 5 power 1 by 3 multiplied with 10 square power 1 by 3, 5 power 1 by 3. Now the two exponential expressions are same, so we cancel them. This is the cube power of 10 cube, sorry, we will change it. This is 10 power cube, 10 cube. Now power cancels to each other and the final answer is 10. In 7th part, this is the square root of 500 divided by square root of 5. So similarly, like previous part, we have to convert 500 in form of 5 to make the base same. So this is first convert into an exponential expression, then write 500 as 5 multiplied by 100 whole power 1 by 2 divided by 5 power 1 by 2. Now by power of product rule law, we separately apply power on the both number of numerators, 5 power 1 by 2 multiplied by 100 power 1 by 2 divided by 5 power 1 by 2. Two exponential expressions are same, so we cancel them. We can write 100 as 10 square, so power cancels to each other and the final answer is 10. In 8th part, this is the square root of 10 multiplied with cube root of 7. As we know that to apply product and quotient rule law, we have to make it possible to make the base same. here we cannot make the base same, so we can write it as the bases are not same, so we cannot. Question number 2 is write an exponential expression as an equivalent radical expression and simplify. So this is an exponential expression. We write it as an equivalent radical expression. Here 3 is the index of 216 and 2 is the exponent of 216. So as equivalent radical expression, it becomes cube root of 216 with exponents 2. So this is the equivalent radical expression of this exponential expression. Now we simplify the exponential expression, that is 216 whole power 2 by 3. So here we write 216 as a factor of 6, that is equals to 6 cube. So we replaces 216 with 6 cube, that equals to 6 cube whole power 2 by 3. Here 3 power in numerator and denominator cancel to each other, so the answer is 6 square, that equals to 36. Part number 2 is the exponential expression 29 with the exponent 1 by 2. So with equivalent radical expression, it becomes square root of 29. So this is the equivalent radical expression. Now to simplify the exponential expression, which is 29 power 1 by 2. So here, as you know that 29 is a prime number, so we cannot factorize it, so this is the final answer. So third part is the exponential expression of two numbers which are written in quotient form. First we write the equivalent radical expression. That equals to, here 5 is the index, so this is equals to 5 as index and the radicand 1 divided by 32. Now we solve the exponential expression further, that equals to 1 divided by 32 whole power 1 by 5. Here we factorize 32 in form of 2, as we can know that 2 power 5 is equals to 32. So we can find the factors of 32 by this process, like 32, 2 1s are 2, 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. So here we count 2, 1 2 3 4 5, so it's 2 power 5 which is equals to 32. We replace this in this exponential expression. Now by power of quotient law, we apply the power separately on both the numbers. So the powers cancels to each other, so the answer is 1 by 2. Fourth part is the exponential expression with the negative exponent minus 2 by 3. So first we write it as an equivalent radical expression. Here 3 is the index and 2 is the exponent of 216, so we write it as cube root of 216 with the exponent minus 2. Now we simplify the exponential expression. So here we write 216, we factorize it 216. So we factorize 216. We know that 216 write as 6 power cube. So we replace this 216 as 6 cube. Here the power cancels each other. We get 6 power minus 2. So by negative power of we make the power negative positive by making the numerator as denominator. The power become positive. So the final answer is equals to 1 divided by 36. Here the exponential expression is 1000 with exponent 1 by 3. So first we write the equivalent radical expression. Here 3 is the index, so we write it as cube root of 1000. This is the equivalent radical expression. Now we simplify the exponential expression, that is 1000 power 1 by 3. So here we factorize 1000 in form of 10, as we know that 1000 is equals to 10 multiplied by 10 multiplied by 10, which is equals to 10 cube. So we replaces 1000 by 10 cube. Power cancels to each other. We get the answer 10. So in last part, this is the exponential expression with the negative exponent minus 1 by 2. So first we make the exponent positive by negative power of quotient rule. How we can make the exponent positive? By interchanging the position of numerator and denominator. Here I make denominator as numerator and numerator as denominator. Now the power become positive, that equals to 1 by 2. So we write it as 39 power 1 by 2, that equals to square root of 39, which is the equivalent radical expression. So this is the final